In this video lecture, we shall discuss about how to evaluate the volume of a tetrahedron given by that is enclosed by the planes x is equal to 0, y is equal to 0, z is equal to 0, and x by a plus y by b plus z by c is equal to 1 using triple integral. Here, actually, first three equations, that is x is equal to 0, y is equal to 0, and z is equal to 0, represent the planes xy plane, yz plane, and zx plane. And the last equation is again a plane that is given with the xyz intercept form. Here a is the intersection of the plane with x intercept, and b is the y intercept, and c is the z intercept. That is, when I take it when I take here three-dimensional plane, three-dimension y, x, and z, we'll get a plane something like this. Okay, this is the point of intersection y-axis, x-axis, and z-axis. So point of intersection with z-axis is 0, 0, C. Y-axis is 0, B, 0, and x-axis is A, 0, 0. Now this will cut the y-x plane along a line which is joining the point 0, 0, C, A, 0, 0. Similarly, again here we'll get intersection line, and here we'll get intersection line. This is something like triangular faces on three sides and also below. So we have four triangular sides. This side, from back side, the equation will be here x will be equal to 0. This side y will be equal to 0, and this triangular face z is equal to 0, and this is the triangle of the plane x by a plus y by b plus z by c is equal to 0. So these are the four triangular faces for this tetrahedron. Now to evaluate the volume of this tetrahedron, see, this tetrahedron comes only in the first octet. Okay. So to evaluate the volume of this tetrahedron, we have volume is equal to triple integral of dz dy dx over the solid S. This solid is nothing but our tetrahedron. This is equal to triple integral. I have to write the limit to determine the volume dz dy dx. Now first I have to write the limit for z variable. Now if I observe here, tetrahedron, this is the below face, so z is equal to 0. It starts from z is equal to 0. If I go upward, we will get the plane x by a plus y by b plus z by c is equal to 1. This is 1, not 0. So this is the plane. So lower limit will be 0, and upper limit we have to write from the equation of the plane. That will be c into 1 minus y by b minus x by a. Now the three-dimensional structure is complete. I don't want that three-dimensional structure anymore. We want to write now limit for y and x. So we have to take the projection on x, y. When I take the projection of this solid, that is tetrahedron, on the xy plane, that is when I put a torch from the top side, I'll get a shadow in the xy plane. The shadow is nothing but the projection. Now I'll get a triangle. Observe only this will be the triangle which will be the projection. That is something like this. I'll get this point is I have A00, but in two dimension it becomes A0, and this point is 0 B. I have both x and y intercepts. So using this we can write the equation of this line. To evaluate the integral or to write the limit, I need equation of this line. That is directly right. I am not going to explain how we get this equation. X by a plus y by b is equal to 1. Now this is our region of integration. If I want to write the limit for the variable y will again varies or vertically start from 0 and ends through the line x by a plus y by b is equal to 1. So start from 0. From this line we have to write the limit for y, that is b into 1 minus x by a minus y by b. So I have to write the limit for y. So I get b into 1 minus x by. Now I have to write the limit for x. Minimum value for x is the y-axis, that is tan for x is equal to 0. Lower limit is 0. Maximum value for x is a here. So it can go up to a. This gives the volume of the tetrahedron. I'm not going to evaluate this integral. Just I'm explaining here how to write the limit of integration. Evaluation part is easier. Anyone can complete that.